Now a little 1/4 watt resistor. So I'll take that one away. Hardly see this guy. Where is he? Oh, there, very, very tiny. Okay, very, very tiny. Well, now if I measure him, again keeping my fingers off of the probes, what do we get there? Okay, this one is 90.7 ohms. Now through experience I know that's a 91 ohm resistor. Resistors go in a standard range, but we'll get to that later. They come in standard ranges, i.e. 2.2k, 2.7k, 3.3k, 3.6k, 3.9k. They are in set values, unless of course you're talking a variable resistor, which can vary from 0 ohms up to whatever the scale is. It might be a 50k ohm variable resistor, so you can vary it from 0 up to 50k ohms or 50,000 ohms. Okay, the next measurement we're going to make, again pressing the mode button, is a diode measurement. Now, a diode will only conduct in one direction. So we put our diode again, here's our diode. This is a pretty simple little power diode. It's a 1N4001 and it will only conduct in one direction and should probably come up at about 0.6 on the scale. So I measured the diode. Where are we? Is the resistor getting out of the way? Diode up there and measure there, and I come up with 0.504. Okay, that's putting the positive on the anode of the diode and the negative, or the black lead, on the cathode of the diode. If I switch it around the other way, it should not conduct. And it doesn't. Okay, that is a working diode. It conducts in one direction only, needing the anode or the positive to be more to the positive source, and the cathode or the negative to be more to the negative source of the voltage supply for it to conduct. There is another way that the diode is used, and that is for what they call back EMF. Which occurs across coils, or like they usually put it across a relay for the collapsing magnetic field when a relay is powered down. I'll attempt to get to that a bit later also. Okay, now I think that's it. Yep, that's it. We've covered the ranges, so we'll just go to the voltage range now. Okay guys, for the next couple of measurements we're going to be taking, which will be the voltage and the current measurement, I'm going to use what they call a bench supply. Just zoom in a little bit. Okay, this is my bench supply. On the left hand side you can see the voltmeter, capable of supplying, the unit is capable of supplying up to 40 volts and supplying up to 3 amps at 40 volts. There's two ranges of current available. There's 0.3 amp range and 3 amp range. I'll get to that in a second. Okay, so there's the voltmeter on the left, then we have the ammeter next to that on the right, and then we have the voltage pot, okay, for supplying the voltage, adjustable voltage pot. And then we have the adjustable current pot, okay, for supplying whatever current is set. Then over here we have the scale, the range, 0.3 amps or 3 amps. Below that we have the amps and volts set. So you set the voltage up, and then you set your current up for the maximum current for that voltage. And then when you've got those set, you turn the switch to the down position Right, this is the up position for setting the amps and the volts, and then when that's ready you press it down into the on to supply the volts at that current rating. That is our bench supply that we'll be using. Okay, so for measuring voltage, what I've got is I've got the bench supply set up, as can be seen here, at 10 volts output. Just come in a little bit, show you the 10 volts. Sitting at 10 volts, I'm now going to put my probes across the negative and the positive contacts on the supply, and we should see on the voltmeter, I'll just zoom in a little bit, we should see 10 volts come up. Now I was saying about auto ranging earlier, at the moment the scale is set on millivolts, but as I measure the voltage it will automatically switch over to volts. So let's have a go at that. There and there. She automatically switches over to 10 volts, and I get a reading of 10.08 volts, which is close enough to 10 volts. 10 volts to 10 volts, that's good. Okay, for this next measurement we'll be measuring amps or current. Now as can be seen, I've got the meter on the 10 amp scale, and on the screen we will be measuring A for amps, which is current. You can quite see that. A for amps. Okay, now for this measurement I put a 10 ohm 5 watt resistor hanging off of the positive supply point on my bench supply. What I will do is I will measure from the negative, then to the positive of the 10 ohm resistor, like that. Now what I'll do, I'll just pan the camera back around. Now if you look at the current scale, it registers, current scale on the power supply, it will register 1 amp at 10 volts. Okay, show me I'm drawing an amp there. Now if I could pan around to the multimeter, it will show 0.996 amps, or 1 amp. It's close enough. So we are measuring current. Now while we're on the story, or while we're on about measuring current, let's just go back and we'll pan this up. And we'll drop this down a fraction. Alright, here we have a formula called Ohm's law. If we look at the middle one, okay, I equals V on R, I is current, V is voltage, and R is resistance. So to find out current, which is what we're measuring, we want to put voltage over resistance. So 10 over 10 equals 1 amp. Okay, I equals V on R, Ohm's law. And that concludes measurements. Okay, country footy oval, right next door to a very large farm. One day game's going on. Anyway, about halfway through the game, the ball gets kicked clean out of the field, over the fence and into the farm neighbouring the football oval. It just so happens to land smack bang in the middle of the chicken coop. Anyway, the ladies are shocked. They all stop pecking and foraging around. And the rooster himself, he takes a look at this ball. He's standing there and observing it, checking it out. A couple of good minutes. Anyway, He turns to the ladies and he says, "Ladies, I don't want to criticise your work or anything, but look at what they're turning out in the other farm.